Hi guys, welcome back to 12.2. This is matrix multiplication. So in the last video we talked about scalar multiplication with matrices, and here we're doing matrix multiplication, which means we're multiplying two matrices together. So looking at this first box, this shows basically the process of multiplying. So I'm going to walk through it. Basically, when you're looking for the first row, first column element, so right this top left-hand corner, this is first row, first column. When you're looking for this element, you're going to multiply the first row of the first matrix by the first column of the second matrix. So you're multiplying row of the first with the column of the second. Okay, so I'm gonna just write that out in detail. So what we're doing is we're multiplying the first element of the first row with the first element of the first column. So that's this multiplied by this. And then adding to that, I'll change color, the second row of the the second element of the first row multiplied by the second element of the first column. So first row, first column plus, so the first element of the first row times the first element of the first column plus the second element of the first row times the second element of the first column. Hopefully this will make more sense as we go. I know it's kind of a lot at the beginning, but basically you're multiplying each element, so you're multiplying first elements together, second elements together, but it's row times column, which is kind of counterintuitive, but we'll talk through it more. So the second element that you're looking for, the first row, second column element, you're going to do the first row again, but this time multiplied by the second column. So if you're looking for the element in the first row, second column, then you're going to be multiplying the first row by the second column. So whatever element you're looking for, its position tells you which row and which column you're going to be multiplying. So then this one, we're going to multiply the first element in the first row of A times the first element in the second column of B. So first row, second column. And then with the second element of the first row of A, you're going to multiply by the second element of the second column of B. So first row, second column. First row, second column. So same thing is going to happen with the second row, first column. We're going to multiply second row by the first column. And then here you're multiplying the second row by the second column. Now again, I think this will make a lot more sense when I do it in detail with actual matrices. So I'm going to move on. So if you're a little confused, don't worry, I'm going to do examples. Okay, so let's talk about this because this explains whether or not we can even do the multiplication. So you can't just multiply any matrix with any other matrix. There are certain things that have to be true in order for the multiplication to work. So we need to look at the dimensions of our matrices. So this is a 3 by 2 matrix, right? 3 rows, 2 columns. So this is a 3 by 2 matrix. This is a 2 by 4 matrix, right? 2 rows, 4 columns. So this is a 2 by 4 matrix. So looking at the matrices of looking at the dimensions of your matrices in the order that you're going to do the multiplying in. So I'm multiplying this matrix by this matrix. The inner dimensions, so the columns of the first one and the rows of the second one, need to match. So the fact that these are both 2s means that I can, in fact, do this multiplication. I can do this matrix times this matrix. And then my resulting matrix will have this many rows and this many columns. So the answer is going to be a 3x4 matrix. So the inside ones have to be the same in order for us to do the multiplication. And then when we do, the dimensions of the result will be the outside dimensions. So note that while I can do this matrix times this matrix, I can't do this matrix times this matrix. I can't just flip it. So in the past with scalars, right, 2 times 3 equals 3 times 2. It doesn't matter which direction we did it in, right? 5 times 4 equals 4 times 5. It didn't matter. With matrices, it does matter. Order matters. So here, if this is A and this is B, I can do A times B, but I can't do B times A because look at the dimensions. If I try to do B times A, then they would be in this order. And these two don't match. So sometimes we can do B times A. Say A was a 2x3 and B was a 3x2. Then I could do A times B and I would get a 2x2 matrix as my result. Or I could do B times A. And I can do B times A, right? And I would get a 3x3 matrix as a result. But even when I can do both A times B and B times A, most of the time, there are some notable exceptions, but most of the time, A times B is not going to equal B times A. Even if I can do it, they're not going to be equal. So sometimes I can't even multiply the other direction, and sometimes I can, but it's still not going to be equal. So A times B is not equal to B times A. Except, again, in very notable situations, that does happen where they are equal, but that's the exception. It's not the rule. In general, A times B is not going to equal B times A. Okay, so all that being said, let's go ahead and do some examples of this. Okay. So, first of all, we're going to look at our dimensions because we need to know the dimensions in order to know if we even can multiply. So this is a 2x2, right? 2 rows, 2 columns, and this is also a 2x2. So clearly I can do this multiplication. These two numbers match. They all match, but importantly, these two numbers match. And my answer is going to be a 2x2. So these match, and my answer is going to be a 2x2. So I can do this multiplication. So let's go through it step by step. So for the first element, so that top left-hand element, I'm going to do the first row of the first matrix times the first column of the second. So row times column, which is why it's these two that need to match, right? So row times column. And now I'm going to do, I'm going to do the first ones times each other. So 4 times 5 plus the second one times each other. So -4 times -6. I'm putting it in parentheses because of the negative. Anyway, so that's going to be the first element. The second element is going to be first row switch to red, is going to be the first row again, but this time times the second column, and that will go here. First row, second column. So that'll be the next element over. So I'm going to do 4 times -6 plus -4 times -1. All right, so now we go on to the second row. I don't want to make this too messy, so I'm just going to erase. So the second row, we're going to do second row times first column. So that'll go here, second row, first column. So I'm going to have -5 times 5 plus -3 times -6. And then the second, this second column, second row, second column, I'm going to do second row, second column. So I'm going to have -5 times -6 plus -3 times -1. Okay, so let's actually evaluate these so we get numbers instead of expressions. So I'm going to write the answer over here because I lack space. So I have 4 times 5, which is 20, plus -4 times -6, which is positive 24, right? Maybe I'll just do a second step. So we have 4 times 5, which is 20, plus -6 times -4, which is positive 24. So 20 plus 24. And here I have 4 times -6, which is -24, plus -4 times -1, which is just positive 4. And then here I have -5 times 5 is -25, plus -3 times -6 is positive 18. Over here I have -5 times -6 is positive 30, plus -3 times -1 is positive 3. Okay, so now for my final step, should be having brackets on all of these. Gonna go off the screen here. Okay. So now for my final answer, I'm gonna write that over here. I have 20 plus 24 is 44. -24 plus 4 is -20. -25 plus 18 is -7. 30 plus 3 is 33. So this is my final answer. It's my final answer for number 7. So that's how this works. Hopefully that cleared things up a little bit. I'm going to do more examples, but that's the gist of it. So let's look at the next one. I'm going to do some erasing here. I might leave the solution. We'll see. Yeah, I'm just going to erase this bit. Okay. So remember, the first thing we have to do is look at the dimensions. So this is 3 rows and 2 columns. So this is a 3 by 2. This is 2 rows, 2 columns. So this is a 2 by 2. So we can do this multiplication. We can do it because these two match. So, and our answer is going to be a 3 by 2. So that's what we're expecting, is for our answer to be a 3 by 2. So the first thing we're going to do is we're going to do more erasing because I'm going to need a lot more room for this. All right. So the first thing we're going to do is we're going to do first row, first column. That's always where we're going to start. First row, first column. So I'm going to do 1 times -2, which is just -2. And 0 plus 6, so the plus 0, sorry, not time, plus, times 0 times 6, which is just 0, so that would be plus 0, which I'm going to write for the sake of thoroughness, but you don't have to, because it's 0. All right, so that's first row, first column. So then we're going to do first row, second column. That's always going to be next. So I would always go across the row first. So first row, first column, first row, second column, first row, third column if there is one, like that. And then once you've done the whole first row, then go on to the second row. So first row, second column, we have 1 times 5 plus -4 times 0 is just 0. Okay. Now we're going to do the second row, first column. So second row, first column. So we're going to do 4 times -2 is -8, plus -2 times 6 is -12, so -12. And then second row, second column, 4 times 5 is 20, plus -2 times -4 is +8. And then now we can go on to the third row. So third row, first column is going to be 1 times -2 is just -2, plus -5 times 6 is -30. So that's that one. And now we can do third row, second column. 1 times 5 is 5. -5 times -4 is +20, so +20. So that's it. That's all of our elements. It's 3 by 2, which is what we expected. So now we can just do the addition and we're done. So the final answer, well, let me put my brackets in. Final answer, -2 plus 0 is -2, 5 plus 0 is 5, -8 plus 12 is -20, 20 plus 8 is 28, -2 minus 30 is -32, 5 plus 20 is 25. And that is it. So we just do that multiplication where you're multiplying the first thing and then adding, and then multiplying the second thing and then adding, and then multiplying the third thing and then adding. That is officially called a dot product. So what we've really done is just like 6 separate dot products. You don't really need to know that name, but if you ever hear someone talking about a dot product, maybe in physics, they do that. That's what we've just done, is a bunch of dot products. But it's just multiplying the corresponding pieces of the row and the column and adding them together. So that's going to be it for this video. I'm going to do some more examples in the next video. And then there will be a word problem example video later. So let me know if you have any questions. Hopefully that helps, and I will see you guys in the next video.